All right, here's question 4 from the GRE practice test. We're still in this little section where we're comparing two different quantities, quantity A and quantity B, and figuring out if A is bigger, B is bigger, they're the same, or you can't tell based on the information given. This time we got a little geometry problem. What we're supposed to analyze is quantity A, x divided by y, where x is the length of this side and y is the length of this side, and 1. So first thing I do when I see this problem is think about when is a fraction bigger than 1, when is a fraction equal to 1, when is a fraction less than 1. Well, a fraction's bigger than 1 if the numerator is bigger than the denominator, fraction equals 1 if the numerator and the denominator are the same, and a fraction's less than 1 if the numerator is less than the denominator. So really all this question is asking is whether x is bigger than, the same as, or less than y. In other words, the question can be restated where quantity A is equal to x and quantity B is equal to y. Because again, if x and y are the same, then this equals 1. If x is greater than y, then this is bigger than this. And if x is less than y, then this is smaller than this. So how do we figure out the lengths of x and y? Well, it's kind of a trig problem, but you're not supposed to know trig coming into this test. So we can do it with a different argument. What I think makes this problem the easiest is to recognize that if this angle right here were 45 degrees instead of 50 degrees, then what we would have is an isosceles right triangle. In case you don't remember that vocabulary word, an isosceles triangle is one where the lengths of two of the sides are the exact same. Another way to state that is an isosceles triangle is one where the measures of two of the angles are the exact same. And if this angle is 45 degrees, this angle has to be 45 degrees because the sum of the interior angles in a triangle is always equal to 180 degrees. That might be worth writing down. So when we have a right triangle, we use up 90 of the 180 right here. So that leaves us with 90 for these two angles. So if half of 90 is down here, the other half has to be up here. Anyways, if this angle were 45 degrees, it's not unfortunately, but if it were 45 degrees, then this angle would be 45 degrees and these sides would be equal length. So if we call this length x prime and this length y prime, x prime would be the same as y prime. But again, that's not the case. This is not 45 degrees, it's 50 degrees. But I really want to harp on this 45 degree case because maybe from this, you can kind of see what would happen if we increase this angle. If this angle is bigger than 45 degrees, 50 degrees for example, then my triangle looks more like this. Note that I haven't changed the length of this side, but by increasing this angle to 50 degrees, I have increased the length of this side. So if you believe that x prime and y prime, the two side lengths in the blue triangle, are the exact same, and kind of see how increasing this angle while leaving this side length unchanged will increase this side length, then maybe you can reason that in this triangle over here, x must be greater than y. So this fraction is bigger than 1. So quantity A is the larger quantity. If I'm being perfectly honest, when I saw this question, this is not how I solved the problem. At least, it's not exactly how I solved the problem. What I instead did, which maybe is worth sharing, is I recognized that the 45 degree case would be the one where these two are the same. And then I noticed that this angle was more than 45 degrees. But rather than kind of think about how things change and draw a blue triangle and a red triangle, what I did is I reasoned that any time this angle is more than 45 degrees, we're going to have the same relationship between x and y. So rather than consider this case where this angle is 50 degrees, I considered a more extreme case. In my mind, I made this angle like 80 degrees or something. It's hard to tell just by looking at this triangle whether x is bigger than y. But in this triangle, it's fairly obvious that x is considerably bigger than y. I knew that 45 degrees was kind of the tipping point, and anytime this angle is more than 45 degrees, whether it's 50 degrees or 80 degrees, I'm going to have the same relationship between x and y. And then rather than figure out that relationship in this kind of close case, I figured out the relationship in this extreme case, because in this one I can tell just by looking at it. X is clearly bigger than y, therefore this quantity is considerably greater than 1, therefore A is the answer.